Now, let's get into the more complex parts of the authentication, and that's what we call the public key infrastructure. This is something you need to understand once. Once you understand it, you'll remember it for life. So you need just to be focused a little bit. So what happens here is that we want to communicate between two persons, for example. And we want to communicate in a way so that we make sure that nobody can read what we're sending. So suppose we have on the left Alice and on the right Bob. Those are the typical names we use in this example. And they want to communicate and make sure that no one else can read what they say. One thing they can do is to generate what we call asymmetric keys. Remember asymmetric keys? You need one key to encrypt, one cipher, but you cannot use that cipher to decrypt. It's going to re-encrypt and re-encrypt again. What you need is another system, another key to decrypt. This is what you would see on top of Alice and on top of Bob. Each of them is going to generate a unique pair of keys. One, for example, the red one, that can be used to encrypt, and the other one, the blue one, that can be used to decrypt. They work together, so what red encrypted, only blue can decrypt, and vice versa. What blue encrypted, only red can decrypt. So these key pairs are unique in the sense that if you have red and you don't have blue, you cannot make up blue. You have to have it. They are complementary and they are unique pairs. So if you have those, Alice is going to generate one, Bob is going to generate another one, so each of them has their own pair. And what they're going to do is to pass one piece of the key around. So for example, Alice is going to give to Bob the red key. The richness of the system is that now what Bob is going to do is to use that red key to encrypt traffic that he wants to send to Alice. And because only the blue key can decrypt what the red key encrypted, Alice knows that only her will be able to read what Bob encrypted with the red key. So she's going to call that key, the red one, the public key, and she's going to give it around to anyone who wants to send traffic to her in a secure manner. Bob is going to act the same way. He's going to give his black key to Alice, and he's going to call that black key my public key. And Alice is going to use that black key to encrypt traffic she wants to send to Bob. And because the black key and the green key are complementary and unique, only the green key can decrypt what the black key encrypted. So that way, Alice can send traffic to Bob in an encrypted fashion. Are we safe? Well, not entirely. And that's because how does Alice know that what she received from who? We don't know. A black key said to be the black key from Bob. How does she know it's really coming from Bob? Likewise, Bob received the red key and it says it's Alice's public key. How does he know that it's really Alice's public key? It could be anybody else trying to pretend to be Alice, creating a pair of keys and just sending the public key out and then interpreting the traffic that Bob is sending back. So what you see, we need a third party in the cloud. We need that guy on the cloud that maybe Alice would know and Bob would know, and they would both trust. If they had that third party, maybe they could ask that person to verify, authenticate that the red key is really Alice's public key and that the black key is really Bob's public key. But how do we do that? Of course, in a physical world, you could go and meet somewhere. In a digital world, you cannot really do that. So we have to find a digital way of making that trust happen. We said that these keys were complementary. So whatever the blue key encrypted, only the red key is going to be able to decrypt it. And whatever the red key encrypted, only the blue key is going to be able to decrypt it. That works for any combination of keys, any pairs. So what is going to happen, in fact, is that the trusted man in the middle on his cloud is also going to generate a pair of keys. One that is going to be public and the other one that is going to be private. And what's going to happen is that that person is actually going to use the private key to sign the traffic coming from the red key. In other words, Alice is going to see that person is going to take the red key and is going to add the text to that red key and say, I hereby certify that this is Alice's public key. And is going to encrypt that added text with the yellow private key. Why? Because that combination now has Alice's key that Mr. Blue in the middle knows and validated her identity one way or the other, plus some scrambled text that is actually encrypted with blue private key. By the way, blue is going to do the same on Bob's public key. He's going to add a text to Bob's blue key and say, I hereby certify that this key is really Bob's public key, and he's going to encrypt that text with the yellow private key, resulting in that kind of key material. So why is that clever? That's clever because in fact, this is what they are going to send to each other. Not only the public key, but also this part that is signed by that third party they trust. Why does that matter? Because that third party will have this public key distributed to Alice and Bob as well. So either when Alice went to see that third party, that person gave to her his public key, or that public key in modern system would already be installed on Alice's system because all this is digital, right? So when you have a laptop, you already have public keys from well-known third parties that can be trusted, like VeriSign, Microsoft, and a few others. And this is clever because the keys are complementary. So what was encrypted with the third-party yellow private key, only the public key can decrypt it. But the public key, it's already there on Alice's laptop, in your laptop, on Bob's laptop. So your laptop has a very easy way to take that key that you trust that was installed with your Windows and try to decrypt that yellow piece. And if we can decrypt it, that proves that the yellow key was the one encrypting it, so that third party really, that we trust, validated that the key is Alice's key or Bob's key. So you see, that's the hierarchy of trust. You start from somebody you trust who is going to sign your key with their private key. And because you also have their public key, you can verify when somebody else sends you their public key that that key was signed with somebody you trust because you received their public key before, and you can use that public key to decrypt the encrypted signature from the key. That system is called a certificate. It relies on this public and private key, and because of that, it's called the public key infrastructure, PKI. The guy in blue in the middle is called the certification authority. That's the guy who you trust, who is going to be at the root of the signatures for all the keys that are exchanged in the system. What you have, that key plus that signature, is what we call a certificate. Every time you go online and use web, HTTPS, secure web, you receive a certificate. And what your laptop is doing is looking at the certificate, which is a key, right, that you're going to use to encrypt traffic that you're going to send back to the web server, that web server being your bank or anything else. But that certificate has that signature at the bottom that your laptop is going to automatically verify in the background by trying to check who signed that key, who was the certification authority, and check if you have the public key for that certification authority. And if you do, you're going to use this public key to verify that the yellow signature is genuine, that you can read it by decrypting it. If you do, you trust that the certification authority did validate that red certificate or that blue certificate. If you don't have the certification authority public key and if you're connected, you can always go and retrieve it if you know where to obtain it. You can do this verification online if it's not already on your laptop. That is possible too, as long as you can check that public key. And again, it's public, so anybody can get it as long as you know you're in a place where you can trust that what you're getting is actually the certification authority public key. And of course, if you already have it, then you don't need to connect to the certification authority and you can do this verification offline without any connection. The trick here as well is that the certification authority is supposed to maintain a list of keys that are valid and those that are not. So if Alice goes away and she doesn't need her key anymore, the certification authority should be able to revoke that key and say that it's not valid anymore. This is why it's very common to do the online verification, not only to verify the certification authority, but also to verify that the key you're reading is still valid.